American Physics Olympiad, year 2020. F equal MA. First round. Exam A. This year was split by 2 days, and each student can choose any of these days to participate. As usual, it was given 75 minutes for 25 problems. If you want to get more interesting problems, subscribe for this channel. Problem number 1. A ball is launched straight toward the ground from height h. When it bounces off the ground, it loses half of its kinetic energy. It reaches a maximum height of 2h before falling back to the ground again. What was the initial speed of the ball? Solution for problem number 1. Let's write expression for total energy when this ball was just thrown. Total initial energy E0 equal kinetic energy 1/2 mv square plus potential energy mgh. After this ball reached the ground, it bounces off and losing half of this energy. So it means that energy after bounce is equal to 1/2 initial energy E0. After that it reached the height 2h. So it means that this energy equal to 2 mgh. Now we can write total expression for this energy. That will be 4 mgh equal 1/2 mv square plus mgh. From here we can find what was the initial speed. That was square root from 6gh. That's answer E, and that was solution for problem number 1. Problem number 2. A rigid ball of radius big R is rolling without slipping along the rib of a right angle chute, as shown in the figure. Which of the points of the ball have the maximum speed? Solution for problem number 2. Points A and B must be stationary because they are in contact with the rib and the ball is rolling without slipping. Because the velocity at any point is given by v plus cross product of omega and radius vector r, where v is velocity of center point O, omega is angular velocity, and r is radius vector for any point. We have VA equal VB equal 0, VO equal V, VQ equal V plus omega big R, and VP equal V minus omega big R. So we can see that the maximum speed will have a point Q, which is V plus omega R, and that's answer E, and that was solution for problem number 2. Problem number 3. When an axe is swung with the kinetic energy E directly at a piece of wood, the edge of the axe is buried depth big L into the wood. If the axe is swung with kinetic energy 2E, how deep will it be buried into the wood? Assume that the axe is wedge-shaped with a constant angle and that the force per unit contact area between the axe and the wood during the impact is proportional to the depth. Solution for problem number 3. We can write expression for total energy, which is integral from 0 to L by force per unit area multiplied by area dx. And here we know that this force per unit area proportional to depth, and cross-section proportional to depth. So it means that F equal K1x and S equal K2x. So it means that total energy proportional to L cube. It means that L proportional to energy E power 1/3, and it means that if we increase energy twice, we will get length equal cubic root from 2L, and that's answer B, and that was solution for problem number 3.